In this example, we are going to compute the average or the mean of a bunch of grouped data. And what we mean by this is we have a class of 13 students that took an 8-point quiz, and the scores are listed in this table right here. And we're going to find the average. So now if you're thinking, well, it says we have 13 students, but if you looked at this table and just added up these possible scores, these four numbers, you'd get an average that's probably 5.5 if you just consider them as 1, 4, 1, 5, 1, 6, and 1, 7. But in this table, we have a frequency. So it shows that the score of 4 was obtained by 2 students. 5, only 1 student got that. A score of 6 students got a score of 6, and 4 students got a score of 7. So as we can see, this frequency table adds to 3 and 10, 13. Okay, so when we compute the average, we'll put mu for the mean. It's not simply going to be 4 plus 5 plus 6 plus 7 divided by 4, not at all. It's going to be 2 times 4, 2 scores of 4, plus 1 score of 5, plus 6 scores of 6, plus 4 scores of 7. And do not put over 4, put over 13, because we're adding up 13 scores. 2 of them were 4s, 1 was a 5, 6 were 6, and 4 were 7. 4 and 6 are 10, 11, 12, 13. All right, let's see if I can figure this out correctly. It would be 8 plus 5 plus 6 times 6 is 36 plus 4 times 7 is 28 over 13. So 28 and 36 would be 50, 64, 64, 64, 69, 77. If I added correctly, I'm going to have to ask you to double check my arithmetic here. So let's see what that turns out to be. 13 times 5 would be 65. So 13 times, I think that's a 5, would be 65. So it looks like it would be a 5, 65 with the remainder of 12, and 12 thirteenths. Let me just check that one more time. 8, 5, 36, and 28. This is 50, 64, 69, and 8 gives me a 77. Okay, so we have 77 over 13. 13 goes into 77. 5 times with the that'd be 65 with the remainder of 12. So notice this score is almost 6, which we would expect that. Look at most of the scores were 6 or 7 even. So the average was not the exact midpoint of 4, 5, 6, and 7, or the average of those 4 numbers. It was weighted more highly, slightly higher than that, which I think I computed 5.5 to be the average of 4, 5, 6, and 7. So this score is just a little bit less than 6. Okay, number 6 is basically explaining what we just did. Given the scores, x1 to xk, which occur with frequencies f1 to fk respectively, the mean is, and then we're going to write down the formula here in a second. Let's make sure we know what we're talking about. This would be like my x1, my x2, x3, and x4. x1 would be the number 4. f1 would be the frequency of score number 1, which would be 2. f2 would be the frequency of score number 2, which would be 1. f3 would be 6, and f4 would be 4. Okay, so all we did is multiply 4 times 2, 5 times 1, 6 times 6, and 7 times 4, and add those up to get the numerator, and then we divided by 13. So let's generalize that. If we've got the scores x1 to xk, that's k different numbers, and these frequencies, k different frequencies, the mean would be f1 times x1, maybe I'll put them both in parentheses just to remind us we're multiplying them, plus the frequency of score number 2 times the actual score, plus, and we go all the way up to the very last one, which would be f sub k times xk. And then what are we going to put for the denominator? Not, well, we don't know what n is, but I'm going to write it as n, and then we'll define here where the denominator n is what? What did we use for n over here? It was 13. Notice where 13 came from? The sum of all the frequencies. That's the count of actual numbers. So n is going to be f1 plus f2 plus all the way up to f sub k. Add up all of the frequencies, and that gives us our total number of samples, or our total number of numbers. So this is the sum of the frequencies. Remember, F stands for frequency. If for the score x1, whatever that number is, F1 is the frequency of that score, and so on all the way up to the last one. All right, well here, this next example is going to be one where we do not necessarily get the absolute exact final answer, because we're going to be using a table that has grouped data. And then this time, it's going to be grouped in different ranges of numbers. So the following is a frequency table of quiz scores that uses grouped data. Notice we don't know the exact quiz score of any one student, because it's grouped data, which we'll see in the chart. So now we are not going to compute exactly. We're going to estimate, based upon the information we're given, estimate the class mean or the class average of the quiz scores. So here's how we're going to do it. The first thing we do is, let's make sure we understand the table. The quiz score between 0 and 5, 8 students got between 0 and 5. So do we know exactly what the scores were? Absolutely not. It could have been 8 zeros. It could have been 8 fives, or more likely it's going to be a sample of numbers between 0 and 5. Between 6 and 10, with a lowest score of 6, a highest score of 10, 14 students. From 11 to 15, 23 students. And from 16 to 20, 10 students. So what we're going to do first, before we do anything else, is let's pick a number for this range. On average, what would we like to say, do we think the average score might be? We're not going to say 5, we're not going to say 0. How about the midpoint of 0 and 5? And the way you get the midpoint is you do this. You do 5 minus 0 and divide it by 2. Sorry, I said minus, it's plus. We're basically taking the average of the lowest number and the biggest number in the range. Okay, and we do that by adding them up and dividing by 2. So we get, for this, it would be 2.5, or 2.5. This is the midpoint of the group. From 6 to 10, this one's easier. If you add 10 and 6, well, it's just easier because we're not getting a fractional part. 10 and 6 add to 16, and the midpoint would be that divided by 2, which would be an 8. So I'll put 10 plus 6 over 2. This is going to be 15 plus 11 over 2. This one's going to be 20 plus 16 over 2. So 16 over 2 is an 8. This would be what, 26? So that would be a 13. And this would be 36. Half of 36 is 18. But remember, we're simply taking the midpoint. If, for example, 10, if we wrote the numbers 6, 7, 8, 9, 10, it's easy to tell what the middle score is, right? It's 8. The reason this one came out differently, 0 to 5, 0, 1, 2, 3, 4, 5, there is no middle value, is there? If you go in 1 and 2 from the endpoints, you go from 0 and 5 to 1, 4 to 2, 3, the midpoint is the middle of 2 and 3, which is 2.5. You don't have to write it out all the time. Simply add the lesser number and the larger number and divide them by 2. I wrote this down here. We have it here. We estimate the quiz score for each range by using the midpoint of the range. That is average of the lowest and highest numbers. Add them up and divide by 2. Okay, so we still have some work to do. We need to estimate the quiz scores, the average quiz score. So from now on, now that we have the midpoints, we can ignore this. And now we're just going to treat it like all 8 of these students received a 2.5 for a quiz score. All 14 of these students received an 8. All 23 of these students received 13. And these 10 students received 18. So the numerator, I'll say my mean, mu, or the average score, is going to be 8 times 2.5 plus 14 times 8 plus 23 times 13 plus 10 times 18. And the denominator, I haven't even figured out the denominator, and they didn't tell us up here. What are we going to divide this by? The number of students, the number of quiz scores, which, this is the frequency, the number of students who received these scores, that would be like the frequency. So 8 students scored this. So 8 and 14 is 22. 32, 42, and 3 makes 46, and that looks like 56. So we're going to divide by 56, and let me get my calculator out. Maybe I'll do part of it in my head here. 8 times 2.5, that's going to be 20, plus 14 times 8 is 80 plus 32. 80 plus 32 is going to give us 112. Let me hold that off on that one. What is 23 times 13? Maybe I'll do it out here. 3 times 3 is 9. 3 times 2 is 6. 0. 3, 2. We get a 9, 9, 2. 299. Hopefully I did that right. You need to double check my work here. And then we're dividing that by 56. And now I'm going to get my calculator. And I'm going to get, okay, I'm going to get 20 plus 112 plus 299 plus 180. All right, hopefully I did this correctly. I got 611 over 56. So if I divide that by 56, I get 10.91. And there is 10.910 and some other numbers, so I rounded off to the hundredths place here. Now let's see if that makes sense. Well, the smallest number that we averaged was 2.5. The largest is 18, and yeah, that looks somewhere right, like it's right in the middle. I'm sure we're not too far off if we made a mistake, but I don't think we made any mistakes. So the 2 steps are find the midpoint of the range of numbers, because we want to just assume, since we're estimating, assume that all 8 of these students got the middle value in here. So add 0 and 5 and divide by 2. These 14 got the middle value here. Add up 6 and 10 and divide by 2 to get 8, and so on. Grouped data.